Hello all, this is Nandini, Assistant Professor, Department of Computer Science at Dr. S.N.S. Rajlakshmi College of Arts and Science. So in this video, we are going to discuss about SLAM, which is nothing but simultaneous localization and mapping in AR. So let's discuss. The simultaneous localization and mapping, which is called as an SLAM in AR. So it is works by allowing AR devices like smartphones, AR glasses or headsets and the devices to map their surroundings and track their own location in real time. So this is a small introduction about AR, and this is the image how SLAM is working in AR. So first we have to capture the data with the help of sensor and which is moves on the front end. So it has some categories. There are feature extraction, data association. So the data association is classified into two types. The one is short term and another one is long term. And next it moves on the back end. So it has two types. The one is estimate camera localization and the second one is geometrical reconstructions. And next it give a output. It is called as a SLAM estimate. And next one is how SLAM works in AR. So let's discuss. So the first step is sensor data collection. So which is nothing but to collect data. It is called as an images. So the AR device use its sensors. So which is typically a camera and accelerometer. These type which is sometimes a depth sensor or LIDAR to collect the informations from its environment. Then the camera captures visual data while the IMU, so which is nothing but inertial measurement unit, which is tracks the motion such as rotation and acceleration. And the next step is feature detection. So the system analyzes the camera which is feed to identify the distinct features in the environment such as edges, corners or textures patterns. These features are used as reference point to track the device position relative to the environment. And the third step is initial map generations. So the SLAM algorithms use these reference points to generate a 3D map of the environment. So this map updates in real time as the device moves. So which is capturing a new features and building out the environment's layout. And the next step is localization. So which is nothing but tracking the device position as the user moves. The system compares the current visual and sensor data with the previously mapped features to estimate the device in a new position. So the system continuously updates both the map and the location of the device, so which is correcting any drift that may occur, so which means minor inaccuracies in sensor readings. And the next step is rendering. So once the pose is estimated, the AR system renders the digital content such as 3D models, animations or information overlays onto the scene in the correct position and orientation. So the content appears to be anchored to the natural features, so it moves and scales correctly as the user or object moves. And the next step is real-time interactions. So the user can interact with the augmented content by moving around, pointing the device at different parts of the scene or touching the scene to interact with virtual elements. The system continuously updates the rendering based on the real-time position and orientation of the natural features. So these are the steps how SLAM works in AR. And the next one is example. So imagine an AR application designed for a museum experience. So first we have to capture the image. The user points their device at an ancient artifact in the museum. Then the feature detection. So the application detect the unique pattern, texture and edges on the artifact surface. And the next step is feature matching. So the detected features are matched against a database of known artifacts which is identifying the specific item. And the fourth step is pose estimation. The application calculates the artifact's position and orientation, so which is relative to the cameras. And next one is tracking. As the user moves around the artifact, the app continuously tracks its features, ensuring the digital overlays which is remains correctly positioned. And next one is rendering. The application overlays the 3D reconstruction of how the artifact might have looked in its original form, along with the information panel and explaining its histories. So these are the steps, example steps for how Slamus works in museum. So this is the assessment and these are the reference. Thank you.